Hello everyone, my name is Chen Yangli. Today I will present a recent study published in Titania in 2024. The topic in the presentation is the multifunctional composite for ultra-sensitive SERS detection and efficient photocatalytic degradation of ciprofloxacin and methane blue. In the introduction, this work aimed to design a difunctional material that can both detect and degrade their pollutant. By combining surface-enhanced Raman scattering with photocatalytic activity, we can achieve both trace detection and efficient removal of contaminants like antibiotic and dyes. And first, for like NiOH₂ microsphere were synthesized through hydrothermal method. Then, several nanoparticles were in situ deposited using butylamine as the reducing agent. These composites were finally assembled onto the silicon wafer for use as recyclable substrate. And this figure shows SEN image figure confirm the successful synthesis, and several nanoparticles are uniformly distributed over the NiOH₂ surface, which is essential for creating uniform hotspot to enhance Raman signal. And the section is elemental mapping further confirm the uniform presence of several Ni and oxygen, and the flower-like structure increase surface area, providing more active site for both SERS enhancement and photocatalysis. And this part is XRD analyzed. It confirmed the crystalline structure both this material and silver, and it is analyzed quantify the element and support that no impurity phase are present. And this section, I want to let you know fluorescence quenching mechanism. This slide explains how carbon quench the fluorescence of red carbon dot or CDs. When carbon bind to the surface of quantum dot, it suppresses layer fluorescence. As carbon concentration increases, the fluorescence intensity decreases accordingly. The diagram shows the transition: bright emission before binding, and quenched dim light after carbon attach. This mechanism enables sensitive detection of carbon ion based on fluorescence changes. And in the method, the researcher used the gluten glutenine and formamide as precursor, and apply a hydrothermal method followed by dialysis for purification. The resulting quantum dot shows strong red fluorescence and 618 nanometer, as shown in the spectrum, and they are highly water soluble and biocompatible, making them suitable for biological or environmental sensing application. And we can see the TN image confirm their uniform nanoscale size and morphology. And this slide shows how sensitive and selective for quantum dot system is for detecting carbon. The detection limit reach as low as 0.375 nanomolar, and we observe a clear linear decrease in fluorescence which with increasing carbon concentration. As shown in our figure, we can see the R squared is 0.999. In terms of specificity, the quantum responds selectivity to carbon with very little interference from other common metal ion like Na, cadmium, or lead. As seen in the bar chart and photos, this result confirms that our system enables both highly sensitive and selectivity in carbon detection. And this section is in vivo detection in plant. This experiment demonstrates how quantum dot can be used to check carbon uptake in real plant. The quantum dot were observed through the root of bean sprout, spinach, and onion. As carbon enters the plant tissue, it quenches the red fluorescence, allowing us to map carbon distribution over time. The image shows a gradual decrease in fluorescence intensity, and the graph confirms the change quantitatively. And this system enables real-time visual monitoring of heavy metal absorption using just smartphone and imaging software. And now we can see the figure. This experiment simulate plant growth using agar medium containing carbon, and we inject quantum dot both near and far from the plant root to monitor uptake. As carbon was absorbed near the root, it quenched the fluorescence of the quantum dot. The heat map and graph showed a clear trend. Fluorescence intensity decreased in the distance from root, indicating efficient carbon absorption in the root region. And this confirmed the system's ability to spatially map metal ion transport even in a controlled medium. And all in all, in the summary, and this composite integrated surge sensing and photocatalyst in one platform. Each enable ultra-sensitive pollution detection and efficient degradation with strong recyclability. And this material show potential for environmental monitoring and green chemistry. Thank you, everyone.